Okay, last but not least, let's get into our tangent function. Now, our tangent function is going to be inverse function occurs, is called the inverse tan of x. And we're going to restrict the inverse tangent to negative pi over 2 to pi over 2 domain. We're going to say our domain is negative pi over 2 to positive pi over 2. The range of tangent was all real numbers. Remember, we could do any value that we wanted. And when we had our tangent values, we had in the tangent values, this is for tangent, we're going to get undefined, because remember there was an asymptote at negative pi over 2. We got undefined. We had negative 1, 0, positive 1, and undefined again. Okay, so we had negative 1, 0, and positive 1. And if you'll see, that is one full cycle of tangent. Well, when we flip that, it's a little hard to plot undefined, and it's a little hard to plot where that's going to exist. But you have to remember that what it basically boils down to is we are inverting our asymptotes as well. So instead of getting an asymptote where x equals negative pi over 2 this way, we're going to make our pi over 2 this way, and here at negative pi over 2. And we don't really usually draw asymptotes this way, but it's kind of still going to be our max and min values. And we can plot negative 1, negative pi over 4, 0, 0, positive 1, positive pi over 4. And that means that we've got negative 1, negative pi over 4, 0, 0, and positive 1, positive pi over 4. So here's my 1, and here, my negative 1, and here's my positive 1. And my graph is going to kind of end up looking like that. Okay? So with the restriction, I'm just showing you graphically why the restriction happened. But with the restriction, we can plug in any value and find our angle value, because tangent has no limitations on its range, and inverse tangent has no limitations on its domain. So let's take a look at the problems that go with it. Once again, we're back in quadrants 1 and 4 here. We're back in quadrants 1 and 4. And so the domain is negative pi over 2 to pi over 2. We can't include undefined. So this isn't included this time. It's simply between negative pi over 2 to pi over 2 with a range of all real numbers. The domain of the inverse tangent is all real numbers, but our answer has to be between negative pi over 2 and pi over 2 not included. Okay, so let's figure out, where is the tangent value 1? Well, we know there's two places with a tangent value of 1, one at pi over 4 and one at 5 pi over 4. Which one is in the quadrants that we're looking at? Pi over 4. So that value is going to be pi over 4. The inverse tangent of negative root 3. There's two places with a negative root 3 tangent, 2 pi over 3 and 5 pi over 3. Now 2 pi over 3 isn't even in the right quadrant, so we can just ignore that one. But 5 pi over 3 is. So let's take a look at that. Is 5 pi over 3 in the output that we're allowed to get? It's not. So how do we find something that is in the output? It's in the correct quadrant, but it's not the right output. Well, we're going to subtract 2 pi, which means we're going to find a common denominator. And 5 minus 6 pi is negative pi over 3. And negative pi over 3 is in the correct output, and it's in the correct quadrant, so that's the answer to our problem. Well, what if we had a problem that asked us to find just the inverse. I don't want you to solve it, I just want you to find the inverse. Now I will tell you there's an error right here, and on the notes, if you look at the notes from online, this is incorrect. We do not restrict cosine from negative pi over 2 to pi over 2. We restrict cosine from 0 to pi, remember? And the range, what's the range values for this problem? It's not negative 1 to 1 anymore because this graph has been shifted. It has a sinusoidal axis or midline at 1 with an amplitude of 3. So 1 plus 3 means it goes up to 4, and 1 minus 3 means it goes down to negative 2. So my domain is 0 to pi. My range is negative 2 to 4. So what do you think the domain and range of my inverse function is going to be? Well, they're going to switch places. So the domain would be negative 2 to 4, and my range would be 0 to pi. But first, let's go find the inverse function. What's step 1? Swap x and y. So we're going to rewrite this as x equals 3 cosine of y plus 1. Now I know you're going to be very tempted to think that plus 1 is in there with the y. There's no parentheses though, so it is not. That is the sinusoidal axis. So let's isolate y. Let's subtract 1 from both sides, divide by 3. Now, if I wanted to isolate y, what would I do? I would do the inverse function. So I'm going to take the inverse cosine of both sides, which will give me the inverse cosine of x minus 1 over 3 is equal to y. That's now the inverse function. So the inverse function is inverse cosine of x minus 1 over 3. And we have isolated the new inverse function. And look at why this makes sense. If I plug in negative 2 minus 1 is negative 3 over 3. That's the inverse cosine of negative 1. The domain works fine. If I plugged in 4 minus 1 is 3. 3 divided by 3 is 1. We have an inverse cosine value of 1. That's fine. Last problem. What if I asked you to solve this problem for x? What am I looking for? I'm looking for a cosine value that would have an inverse cosine times 2 equal to pi over 2, equal to angle pi over 2. So I'm going to isolate x. First step, divide by 2. Now dividing by 2 when you have a fraction can get messy. So I'm going to multiply both sides by 1/2. That would cancel, leaving me inverse cosine of x equals pi over 4. So I'm asking you, if I want to isolate x, what do I have to do? I have to take the cosine of both sides, so that I would have the cosine of the inverse cosine of x equals the cosine of pi over 4. Well, what's the cosine of the inverse cosine of x? Well, x is in the domain. It's actually written into the problem that equals x equals the cosine of pi over 4. Well, what is the cosine of pi over 4? Root 2 over 2. So x equals root 2 over 2. So if I took this problem to check it, 2 times the inverse cosine of root 2 over 2. The inverse cosine of root 2 over 2 is pi over 4, and 2 times pi over 4 is pi over 2. There's the answer that we started with. We know that the right solution is for x to be root 2 over 2.